Very good afternoon to all. I welcome you all to the last plenary session for this conference. To deliver the plenary talk, we have an eminent professor, Dr. Hakan Kaleli, who is a professor in Department of Mechanical Engineering, Automotive Division, Yildiz Technical University, Istanbul, Turkey. To give you a brief introduction about the speaker, he has done his master's and doctoral degree from Yildiz Technical University, Israel, and he has been associated with the university from 1986 to till date, and now he is a professor in the automotive division. His area of expertise and interests are internal combustion engines, lubrication and cooling, engine tribology, engine oils and additives, and many other. He has published several journal and conference publications. So now I request Professor Hakan Kaleli to deliver his plenary talk. Thank you.
And I will present about additive layers formed on the surface between sliding pairs. And so I am working on that for many years. So the title is Review of Layer Formation on Engine Oil Additives on the Rubber Surfaces from Micro to Nano Microscopic. But it's a huge story that I will talk about it. But before to go on, I will introduce a little bit about my university. This is just here is the main campus. We have two campuses, and I am in the main campus. This is we are happy because as National Institute of Technology, we are in the green yard. So and this is a single university who are in the green between trees. But it's on the hill on the top of Istanbul. Istanbul is situated in 7 hills. So this is one of the hills. Well, we are lucky. I am lucky with my university is on the hill. And so this is the entrance. Well, it is founded in 1911. And there is 10 faculties, 2 institutes, and more than 23,000 students. At the end of this is the Bosphorus Bridge, very famous. As you know, the Bosphorus Bridge separates the European side and Asia side. But European side and Asia side also, Istanbul is divided in 2 sides. So every day I cross this Bosphorus Bridge. And when I go to the top, on the hill, here is my office where we are lecturing. Well, I am in the mechanical engineering faculty in mechanical engineering department. And there is in our faculty 66 staff. 7 subdivisions, like automotive division, heat and transfer, etc., manufacturing. And we have day and night education, and total 600 students. So I am in automotive subdivision. This is automotive subdivision, and mostly we have engines and engine test rigs. First of all, I would like to thank very much to the coordinators inviting me to this conference. It's an honor for me to be in this conference as a keynote speaker. So you know that the tribology is the science and engineering of interacting surfaces, relative motion. So my application is mostly on lubrication, and this is the part of tribology, which includes by lubrication, I arrive to the wear and I produce fracture. it's a huge story because I started that story in 1999, 15 years ago. And I worked on some test rigs with oils, but engine oils, and I obtained on the surface protective layers of additives. Well, yesterday or before yesterday we talked about prediction, and this was not prediction. I didn't predict to find protective layers on the surface, but after test, when I found it, then I did more prediction. Well, this is carried out in, first of all, on pin-on disc experiments. I will show you shortly. And I have found the formal tests on the surface, the formal testing conditions. And this can apply to every test rigs. So by chance, as I found this, so you will see an exhibition. That this is a carpet exhibition. And my wife is in the art faculty at Sakarya University in Turkey. It's another university, a bit far to Istanbul, about 1 hour and 30 minutes. So we joined the science and art. So she waved my tribology pictures, photos on the carpets, where you can see on the exhibition. This is a poster. I'm sorry because she couldn't come because my mother-in-law was sick and she's in hospital, so she's so sorry not to be able here. Well, let's go to the work now. So you see here you will see pin-on disc, pin-on plate, and another pin-on plate machine. Well, first of all, I did many tests on pin-on disc and pin-on plate machine, and I have found the formal testing conditions. So I will talk about those in details later, but just to explain you the details, the outline of the work. So taking into account these conditions, we wanted to see, to film, to visualize the surface formation. How we obtained it, that we wanted to see it, and we did it. And these were presented in X congresses. Then, as we have seen the surface, so we wanted to measure the thickness, the layer thickness of additives. And we arrived at to do it. So you know, on pin-on disc and pin-on plate test rings, we have specimens, but those specimens are mostly steel. So the steel 50,100 or 51,115. These are regular standard specimens, standard material, were used in everywhere in the world. But as we found the protective layer on the surface, as I'm in the automotive division, so I was very interested to see those layers, how they formed on the cylinder liner in internal combustion engine. And so we did more experiments, and we detected those layers. Also, we compared cylinder liner with plates of the test rig in another conference. Then we started to go from micro to nano, because at that time we were investigated using optical microscopy and electron microscopy, but then furthermore we went to the and we arrived at to measure, to find those additives on nano tribology, on nano measurement with AFM. When we were doing some engine tests, we detected very interesting results, which I presented also yesterday, some of them. We tested different piston rings on the cylinder liner, on test rig, and it was very interesting because, you know, oil contains some additives, mostly, you know, ZTTP, calcium sulfonate, etc., like anti-wear agents, oxidant, antioxidant, etc. And on the oil ring, not the compression ring, not the first ring, not the top ring, the second ring, on the surface, we detected zinc and phosphate. So they cover, they coat the second ring, oil ring, by zinc phosphate. So this is very interesting subject, and we are working on it, and I have PhD student. And so this work will be carried on more. As in the oil, there are zinc and phosphate. So the zinc and phosphate also remove from the surface, and it contaminates the oil. And so this can be very dangerous because, you know, there is a composition of oil in the fully formulated lubricant. We have everything. And if you add some more additives on the oil, it can be dangerous. It can be maybe positive, but mostly there is an antagonist effect, not synergetic effect, which degrades the lubricant. So we caught this, and we talk with some pistoning companies, and we are talking more on that. And this one is presented yesterday, but I put some more slides to show you here. Well, next feature is just to compare really the zinc phosphate and without zinc phosphate, do more tests on pinion, on reciprocating pinion plate test rig, and also in the engine. So we finished some experiments on pinion plate, and we are carrying out now, we set up the engine on engine test. So we will see the surface of the liner and also piston rings, but using the right piston rings also. Well, to obtain additive layers on the surface, on the sliding surface, what we need. So this is general information. Just to remind you, there are two processes, one chemical and the other mechanical. As we are mechanical engineer, I am mostly interested in mechanical part. So the rest, so I'm sorry about chemists, but they do more tests on, well, EDS, reactions, etc. But in mechanical part, you can see. So what I would like to explain here, in type of lubrication, if it is hydrodynamic, so if there is oil and separated two surfaces, on the surface, we don't obtain the layer, the protective layer we wanted. What we want that the all additives form on the surface, cover the surface, like you paint with brush the wall. Because on hydrodynamic lubrication, if two body doesn't touch, there is no surface degradation. The surface must be degraded, and the degree of the surface degradation is very high. If it is dry friction, the surface is much more degraded than the additives do not form on the surface. But this degradation is very important. So it must be slightly degraded to make attractive the surface, a bit flatness, suitable, where this favor chemical reactions. So all the chemical reactions occur, and you have layer on the surface. Of course, temperature, load, and sliding speed, which are mechanical conditions, affect those formation of layers. Well, many years ago, 15 years ago, I was invited to France, Lyon, France, and there is a big tribology lab there, and I wanted to do tests, as I did in my PhD thesis, lubricant test on pinion disc machine. And very interesting, you know, this configuration. Just I would like to take your attention, because it's very important. If you do the same test on pinion plate, machine, you don't get additive layers. But in that one, we did some more tests with lubricant, with also additives. That time, oil 45 was very famous, etc. And just to see the friction, the behavior, the surface analysis, etc. In that point, you know, on pin on disk machine, when disk turn around, so it's always a continuous, it doesn't stop. But on pin on disk, it stops, like in engine. In engine, you know, stop at top dead center and bottom dead center for a short time. And this affects the layers on the surface. That's very interesting. Well, that time, just I would like to take your attention. Here, the boundary lubrication as a friction coefficient was 0.1 as an average. And so we did friction tests with different kind of oil. And what we obtained here, we obtained, well, this is the pin surface, this is disk surface. There is no oil here. Because dry test, that first of all I wanted to see what happens on the dry test. I was curious about it. And it's all worn out, scuffed. You see the surface is not very interesting. So we did those tests with oils, engine oil, and additives. Well, I didn't predict this, but what we found really, on the surface, the pin surface mostly, it was covered by, it was very colorful. Then when we investigated those colorful things, the additives, when you look at the light microscope, optical microscope, they are colorful. So like Einstein, I said, oh yeah, we found this one. It was very interesting. So you see the protective additive layers on the surface. So I will show you many examples on this. And that time, scanning electron microscopy was using only Polaroid photography. You cannot measure like this very electronically like in nowadays. And also optical microscopy, that time it was very difficult. There was not a digital camera, just we put the black and white camera, then we changed it to we bought a very special camera, the color camera, and we got these pictures. So we developed these pictures. I keep still the negative slides. So you see here that the pin surface, this is, there is no rubbing here, but the rub surface here and the one surface here are slightly degraded. And if you investigate that surface, you will see that very additives are coming out by SEM and X-ray analysis. So these are examples. And I did publication this in Industrial Lubrication Journal that time. What I would like to inform you here, this is the disk surface, because the pin material is different than the disk material. The pin material is a steel. The disk material is a steel also, but on the disk material, there is much more chromium on the surface, on the material in the composition. So that time, even other times, the layers only mostly formed on the surface of the pin, but not disk. Of the pin, but not plate that time. And maybe I show you here, like here. You see this is disk surface, and just I could investigate that part, in very small part, like islands form layers on the surface. There is, but not too much. Then we did some SEM photos. So when I investigated on SEM, well, I found on the surface those additives formed on the surface, mostly because the oil contains calcium, phosphorus, sulfur and zinc. And when you go deeply in a higher magnification on SEM, it is like you are flying between clouds on the air. So you see, it's like clouds, and very interesting. In the part of the disk on the surface, those clouds are much more visible. You see, that part is not well viewed. You see the liner finishing parts, and it's like clouds here. And these are additives. In next step, we wanted to do those tests in pin-on-plate machine. So France has got a very nice pin-on-plate machine, so you can do it lot of tests. And we did tests on pin-on-disk machine, pin-on-plate machine, sorry, with this is the pin and plate, the surface. As the movement was continuous on the pin-on-disk, we couldn't be successful. We did the same conditions on pin-on-plate, even pin and plate. Well, we obtained some additive layers, but it was like islands. So I always saying, you paint the wall, and the wall is not painted. Just if you brush your brush, you put into the paint less, so you don't paint very well. But if you have more paint, more color paint, and it's a thick, then your wall is all painted. So in that case of pin-on-plate, it is not well painted. It is not before the additives layers formed like islands. So with that machine, we found the continuous way, because it's charged, loaded, unloaded, loaded, unloaded. Then every time when it is loaded, it was on the single way. Well, we did many tests, step loading, dropping the oil, etc. Only 3 drops of oil here. 1, 2, 3. Then you make line, and on those conditions, well, arrived almost 0.11. We obtained layer full covered pin surface. Well, this is the example of the pin. So you see, this is the optical microscopy, and in higher magnification, and it's very colorful here. So if you make SEM, so you see that the calcium, phosphorus, and sulfur exist everywhere. It's very nice. So it's well done. My wall is painted here. So this is the formal conditions. So, and we did the other tests taking into account these conditions. So I compared the pin disk and pin plate results, just to see, to compare them. This is before for the pin and disk of optical microscopy and SEM. This is the pin of the pin-on-plate and SEM. There is a material effect also on the surface because 50,400. The slide I showed you, we obtained the layers with the pin material 50,100. Yes, we obtained it. But it is a bit harder than 51,115. And on 115, we obtained more layer on the surface. And because there is the surface degradation is very appropriate to adapt to the surface to get slightly nice surface, flat surface, where the additives chemically react on the surface. And when you wash the surface, because it's not like that. Okay, I found it. No, no, it's not like this. Before test, you wash the surface. The surface is much more clean. Nothing on. It's dry. You do test. Then you take off. You wash ultrasonically. Well, that time we washed with hexane, and now they forbidden hexane. It must washed by heptane, and even hexane or heptane. When you wash the surface, the oil gone, nothing on the surface. But additives, layers remain on the surface. They don't go away. So the slide I show you, and I will show you more slides, that every test is after washed the surface and dried, then examined on optically and electronically. Well, this is the pin surface of pin on disc. Well, on that surface, with pin before and after, we found additive layers on the surface. And you see the SEM is like close. And just if you keep in your mind, you see we came up to the 10,000 magnification. It was very difficult because when you increase the magnification, after some magnification, after 5,000, it's getting difficult just to focus the real surface. And we could focus it with a different way. So you see these are additives layer on the surface. And when you look at the still calcium, sulfur, and phosphorus exist on the surface that formed layer. On this surface, as I told you, it's another material because this is 51,115, and the disk is 42C, where in the material there is much more chromium. I have another slide where I know the composition, so if you are interested, I can. Well, this is the plate surface. On the plate surface, not much. I passed this one. Well, how we obtain these results? What is mechanically? What is this? What is the answer? The answer is this. Well, not only chemical mechanism, but also mechanical mechanism is the main factor which play an important role on the activation of additives to form additive layers on the surface. And tribological experiments prove that the temperature is very important. When you increase the temperature, the reaction is getting fast, and the additives form better on the surface. So the temperature is a chemical factor, and the material, eventually the material, is a mechanical factor affecting the formation of additive layers. Formal test concluded that the surface degradation is a mechanical action. The surface must be degraded slightly to form additive layers. For this, I don't put in the slide because it takes a long time, so I must talk up to evening. Just what I mentioned, we did some small dry test, short dry test, 1-2 minutes, on the same conditions. Then we put the oil and we keep on the test. As on dry test, the surface is well degraded, then in the next step, we carry it out the test in 42 minutes, and the additive layers formed on the surface were much higher than regular test. So that proves that surface degradation is so much important in that. Well, the main mechanical mechanism, what is the main mechanical mechanism? Is surface degradation, as I told you, which favors and contributes chemical reaction on the surface. The degree of the surface degradation is very effective. If there is a very high deterioration, if the surface is much more degraded, or there is scaffold, dry test, is the material gone? Is that possible to get additive layers on the surface? Because there is a deep grooves form on the surface and prevent the production of chemical reaction. What I showed you in my first slides, the dry degradation is very harmful. But if you have adequate degradation, efficient flatness of surface, make it reactive enough and activates lubricant additives to form protective layer on the surface. This is the main mechanism. After this, they ask us, is it true what you do? So I showed you the photos. No, we don't believe it. You must take the film, prove it by the film. So what? How? What we did, instead of pin, we put a sapphire pin, and behind the high-speed camera, but plate with the pin material, and we film it. We filmed the formation, and we proved it. That was very interesting. So I show you. This is the pin sapphire on the plate, and the steel strip, and we motored the experiments where we found the additive layers, because on the same conditions, and we had a smooth surface flatness where we obtained the additive layers on the surface. Yeah, this is the test. I will show you shortly the visualization. It takes a few minutes. It's a short, it's a long test, because the usual test, it's a formal condition test, takes 42 minutes to obtain layers. So you see the pin material, new one, and this is used one, SEM, and X-ray, and we have additive layers on the surface. So this is the beginning, middle, and end of the test. I hope it will work. You see the beginning after this? Now, loading, unloaded, loaded, unloaded. If you can see, you will see the white patches, white points on the surface. The white patches are more visible. So at the end of the test, these patches are formed as additive layers on the surface. You see these patches is getting more. It's increasing on the surface. That's very interesting. You see? Much more visible. Much more visible. Yeah, you see, covered like this. Here is they start to be. Then we change the setting of the light, and to see better the colorful layer towards the end of the day. You see, they are much more visible. That's very interesting, incredible. Yeah, we change the light. You see all the surfaces very well. This is towards of the test, the last seconds. I presented this in, I think, as I remember, in maybe Washington, D.C., or I don't know, in World Tribology Conference. And the Japanese came, and they asked, how you found it? How you found it? How did you do it? So I tried to explain, but it was difficult. Now it's all covered. You see, it's more darker, more visible. Well, you see the on the pin, you have seen the layer, and you have seen the formation of the layer. The pin I showed you. We did then after we carried out different tests with material 51,150, and we tried to measure the layer thickness. So you see the pin, this is the pin surface. And, so we could cut it in two parts. And we look at that direction. And in different magnification, we could detect the thickness by ACM. It was very difficult, but maybe I am lucky, and it was very interesting. So I show you only 4,000, because we did 5,000, 1,000, and it will take a long time. But you see here is non-variable, and I put here the ACM and X-ray. So we did cartography, calcium, phosphorus, and zinc. It's very, very colorful and really protect the surface. Is it true? Yes, because we have X-ray, and on X-ray you see calcium, phosphorus, and sulfur detected on this part. But here there is nothing. And we did some statistical results. What we did from 500 to 4,000 magnification. We found the results, and we did those tests 3 or 4 times to be sure. So the calcium was minimum. Then after sulfur, phosphorus, and zinc. Zinc was very high. I think because of the protective against wear, as it is anti-wear agent in the lubricant. So we did some statistical more, and we measured the layer thickness with different magnification, and we arrived at those thickness vary between 0.75 to 11 micrometer. Well, you see that these are layers formed on triple-test ring. But as we are mechanical engineer and I'm in automotive division, I wanted to see those layers in engine. And then we carried out a diesel engine, 22 hours. So this is the engine. We did this one with one of the master science students. And we carried out engine test. And you see the cylinder liner. We cut it the cylinder liner. And after test and before test, the Total company supported us. So we did the oil analysis and engine performance test. We found in what conditions we must carry out the test, operating condition. Then after we examined the surface. As a result, you'll see that this is cylinder liner. This is new one with honing part, and this is ACM. So you see the material. On the surface, there is no additive layers. There is no additive, so it's normal. Yes, this is the top dead center. Well, in my other presentation, we have all results. So I show you short results that mostly top dead center and middle center. Then we compare it with also with the plate examination. And the plate is cut off from the engine. It is the same plate cut off and set up to the test ring. And we tested it with the same oil. Very interesting. You see this is the top center, just below the 800 micron to the top dead center. And top dead center is not in line. When you look at the surface, it's like in line. You see here is then start the combustion chamber. The combustion chamber is much more black. Even I have some more fabrication, more work on combustion chamber too. I examined also combustion chamber. And if you examine combustion chamber, it's horrible. It's full of the additives. But all carbonous residues, but also you find zinc, phosphate, calcium, all kinds of additives on the combustion chamber because of the combustion burn also. So this is the different higher magnification, and on that magnification, we also measured the additive layers. Yes. So what happens here? As I told you, if you do test on pin-on plate machine, so in regular tests, it stops at the top, at the both ends in plate machine. And what happens in the engine? Also, it stops at the top dead center and bottom dead center. What happens for additive layers? The additive layers form as islands on the surface. Not everywhere. They don't cover. And mostly, we found those layers at the top dead center, because top dead center is the worst condition under boundary lubrication, and there is high load, maybe high temperature, but where this compression occurs because of the good compression, no leakage, no blow-by, and the additives really play a good role to protect the surface. Even that protection, very small, when it is sliding, there is no blow-by, nothing, there is no leakage, except if the engine is not warm. Yeah, you see this is the top dead center. Here is colorful, but if you look at, well, this is a X-ray of SEM, and you see the zinc, calcium, sulfur, and phosphorus. Well, I compared this with engine and pin plate test rig. So if you compare this one, you will see this is a new cylinder liner, and we use the plate, the same plate, even the same plate sometimes cut it from the engine. If we couldn't cut, if there is, we honed on the same conditions. We measured the honing, we did honing measurements of the liner, and we honed again the plate. But in my last tests, I did other tests, but I don't show you here. We have been successful to cut plate pieces from the engine. It was difficult, but we did it, and we did many tests. Yeah, this is the top center. Here, 800 micrometer, and this is the plate. So you see, it's very similar. We found very similar conditions and very similar layers on the surface. It's covered. Yeah, this is the top dead center. What happening here? Well, you see, in some points there is only phosphorus, because this is layers, additive layers, but as islands. In some point, it is not covered on all the top dead center. Yes, as in the plate, I showed the optical photo, so it's the same. This is middle center. Middle center is a hydrodynamic lubrication, is a mixed lubrication, but and where the additives form less than top dead center. In that case, it can be more, because we don't know the friction behavior, but generally it is less. And in some cases, at the bottom dead center, in that cases I haven't found any layers. It was nothing. But I did some other tests, and mostly, as there is boundary lubrication at top dead center and bottom dead center, and stop everywhere, more additive layers found in both sections. You can compare the color with top dead center and plate. You see, it's like islands. Even in the plate, it's like islands. And very interesting, in the honing grooves, yeah, we found those layers. Well, it is usual, because why? You know why they hone the surface? So you know it, to maintain the oil. If there is oil starvation, that these pockets help for rubbing and not to protect the surface. Yeah, we go now from micro to nano. We carried out again several tests on pin plate machine with commercial oil and base oil. Because to compare the both surface, we need the test carried out by base oil and what happened with commercial oil. Well, this is the test with base oil. So you see any additives on the surface. And just we carried out some tests by AFM here. And this is optical microscopy, but no additives here. This is carried out by base oil. Well, you see the surface is quite light. And you see this is the commercial oil. We did AFM here, and zinc, phosphorus, calcium, and sulfur. It's full of here, covered the surface. So you see this, my wife waved on the carpet, this one. Very interesting. And at that time, we found layers on the pin and plate because we used the same material. The material wasn't different. That time it was different, but now even the plate and the pin played a role to form protective layer on the surface. You see, this is much more darker because the surface is well degraded and well formed layers on the surface. Well, this is the optical and SEM microscopy, non-used, used, and we did AFM. Well, shortly I will show you better AFM in 3D. What we found here, the test carried out by base oil, the surface is much more rough. But there is a smooth surface with test carried out for pin and plate. That's very interesting. And we did some force distance curves. We found more force for the test carried out with commercial oil, where there is additives. And we did adhesion measurements. And the adhesion measurements showed that higher forces on the surface of the pin and plate carried out by commercial oil than base oil. Even adhesion force measurement here, and also the friction velocity, etc. You see, it is much more higher than base oil. Yeah. Now we think that why it is high, because it shows more adhesion. Well, we are searching now this because the viscoelastic effect of additives. It is difficult. They are more sticky when you do measures by AFM on the tip. As I told you, I did some more tests, and I presented this in Sofia Technical University just last year, towards the end of the year, because we found very interesting results with the test carried out on the machine, on tribo test machine, but we detected zinc and phosphorus on the ring surface. So you know there is two rings, one compression ring, the second ring, oil ring, is oil ring to scrape the oil, and on the oil ring is covered by zinc phosphate, but the top ring is coated by chromium. Yeah, I did this test in France. So they provide us a pneumatic test rig. It is controlled pneumatically, and the 3 distance sensors can go up to the 500 degrees centigrade. And very interesting. Well, I am designing now new turbo test. It is universal, which can be pin on disc, pin on plate, ball on disc, ring and liner, etc. So very interesting. The lamp, there is an infrared lamp here. It doesn't touch, and it hits the both surface, the both pin and liner. So it's very interesting. Well, I hope there was noise, but So what we did in our experiments, we cut it, piston rings and cylinder liner, and we installed here. You see there is holders here, and I presented yesterday this one, but I will show you in my, I edit here in my last slides. I will show you some results, and this one is cutted. The holders we prepared in Turkey, all the holders, and very strictly, very preciously, we cut the piston rings and cylinder liner and put in the holder, and placed on the holders. I did almost 1 month tests without obtaining anything. It is very difficult because if you don't cut precisely, you cannot place appropriate on the cylinder liner the piston ring, and the piston ring diameter must be small than the cylinder liner, because you cannot rub both of them. So what we did, the engine, this type of engine has got different types. So we got the piston ring of the smaller engine and liner of the bigger engine, the same material. Then we cut it precisely, and we put to the holder, and we tested this. Yeah, this is the configuration. And we did some surface analysis. This is new cylinder liner. On the cylinder liner, there is nothing. But, no phosphorus, no zinc. This is cylinder liner after test, carried out by oil ring coated by zinc phosphate, secondly. And it's very interesting. On the cylinder liner, we have found full of the additives on the surface. But on the oil ring also, that's very interesting. And on the oil ring, after test, the amount of additives also was high. And then we asked the question, so if those additives influence the lubricant. Sorry, this is before test, new test, new piston rings, I'm sorry. And this is a used test. Even after test, in different magnification, we have all additives like calcium, zinc, phosphorus, and also the calcium is very interesting because on the coating they use also calcium. There is an amount of calcium, but also this can come from the lubricant. Well, I presented this one, but I will show you some results because there is AFM results here. This result just be obtained a few weeks ago before to come here. This is the chromium coated test. The test carried out with the liner by chromium coated piston ring. I have also zinc phosphate coated ring. So this is optical microscopy, where you see on the liner of chromium coated ring we have additive layers, and 5 points is measured by AFM, and you see the number 1 and number 2 is showed here. In number 1 you see the white patch here, and there is white patch here also, but there is dark patch here, dark patches here. So these white patches are layers, are additives on the surface. What we know that point here, and also we know the point by ACM. Well, the point 2, we catch those layers. If you remember, I showed you one ACM photo for 10,000 in 10,000 magnification. This is the same structure, so we are happy on that. Well, thank you for your attention, and
Thank you, sir. Any questions, please?
Sir, what is the coating procedure for zinc phosphating?
Yeah, I visited that company, and just first of all, I would like to mention they didn't like what I found because they stopped coating on for heavy vehicles, for camion and trucks, because of the degradation of the oil. And why they coat it? Well, I will tell you. This is for shelf protection, because in the new engine, when the engine came out, it is new. Generally, it is not coated by zinc phosphate, but on the shelf to protect against corrosion, they coat it, and they coat between 3 and 5 micron. And now I am searching to coat it by different way, not zinc phosphate, and shouldn't be any additive elements. We carried out with the test with the piston rings. We call it white rings, and we had successful results. Also, I am looking a partner to coat the surface, for example, by some other coatings like yttrium coatings or else.
Is it possible for going manganese phosphate coating instead of zinc phosphate?
Any?
Manganese phosphate.
Magnesium phosphate.
Yes. Manganese.
No, but in magnesium phosphate there is phosphate. If there is phosphorus, this is the problem.
Thank you, sir.
Any more questions?
Sir, they are adding the additives to the oils. They are adding additives to the oils.
I am not adding.
Generally, these lubricants, they add additives to the oils to increase the performance of the engine.
Yeah.
But when it is found that in the experiments, when you add these oils, because of the addition, the friction force increases.
You mean in full form in the oil, you add some additives?
Yeah, we added some zinc nanoparticles in the.
You did this test?
Yeah, we did.
But I did also.
We did 4-ball test, and we found surprisingly the friction force was
Yeah.
increasing.
I understand. But if you ask me, I refuse it, because now I did the engine test, even fleet test in Turkey, and adding, for example, there is boron. Boron is very famous, and so they added this boron, and they say even nanoparticle bores. But I tested in the engine, and you know what happens? Those elements are coming down of the crankcase, and they produce sludge. So on the filter, and you must change the filter every time. And frankly to say, I found sometimes worst results because of increasing of the viscosity.
We didn't have confidence to proceed ahead with the things, because what these oil companies, they claim that adding additives reduces friction and thereby increases the performance of the engine.
They sell to sell this.
We didn't have confidence to proceed ahead with why that friction is increasing, whether we were on the right track or we were on the wrong track.
But this is trade, and I talked to some companies, and they came to me because in my lab I produced a new device. What to do to see the friction effect of any oil. We drive, this is motoring test. I don't know if you heard it. So we do motoring test. We drive with electrical engine, the internal combustion engine, and we put different oil with the same on the same but new engine, and we try to find if you add some additives, etc. Sometimes we measured it very accurately. Even I have a PhD thesis for this, my student. But sorry to say, even the best I tried, for example, from I know Professor Ali Erdemir. So even now he doesn't work on that subject because I talked to him. It's a trade. I tested power up, motor up, double up, motor silk. I have all results. Bore. Even bore in my country, it's well developed. You find.
Any more questions, please? Okay, if there are no questions, let us thank the speaker again. So on behalf of the organizing committee, as a token of gratitude, we would like to present a small memento to the speaker. So in this regard, I request Professor Lakshmi Narayanan, who is principal of JNN Institute of Engineering Technology, to present a memento to the speaker.